This conference will now be recorded.
Hello, everyone, and welcome to the Satellite Book Club seminar series. The title of our talk today is Geostationary Lightning Mapper Science Team Meeting Review, and our presenter will be Joseph Patton, Assistant Research Scientist from the Cooperative Institute for Satellite Earth System Studies at the University of Maryland, also called CISESS. And our facilitator today is Nick Corletta, meteorologist from WFO Minneapolis. Before we begin, just a few opening remarks and reminders. As usual, the session is being recorded. We'll take Q&A after the main body of the presentation, and we encourage you to post your questions in the chat room. The TOWS team and the facilitator will help field them from there. We tend generally field the Q&A at the end of the main body of the presentation. Most of you already doing this, please sign in with your full names and also specify your full names when asking a question in the chat. That helps us keep track of who's asking what questions and helps us follow up with you afterward with answers that might come in after the meeting. Always looking for future presenters, contact the TOWS team. There'll be contact information on the slides. And the training team can help create training materials for you or identify training materials that are available that might be relevant to a talk you want to give. And for that, please contact Brian Mata, who can field questions and information related to that. Thanks, as always, to the TOWS team, Kashad Bowman specifically, who gets us all lined up here, but also his colleagues on the TOWS team, Office of the Chief Learning Officer, OCLO, GOES-R and JPSS programs, and our presenter and our facilitator. Joseph, before you begin, just want to say a few words about your bio for those who might not already know you. Joe is an assistant research scientist with CISESS, and his focus is on lightning research and training. His current position involves studying operational forecasting techniques using the GLM, the Geostationary Lightning Mapper, and creating training materials based on lightning information from the GLM for forecasters around the Western Hemisphere. Joseph graduated from the University of Oklahoma in 2015 with a BS in meteorology, and from Florida State in 2017 with an MS in meteorology. He served as an operational meteorologist with the Weather Service for 2 years in Goodland, Kansas, before joining CISESS here in the DC metro area. Joseph, welcome back to the Satellite Book Club, and the microphone is yours.
Thank you so much for that wonderful introduction. It is a pleasure to be here. And just to confirm, it seems like you guys can hear my audio. Is that correct?
Loud and clear from here, Joseph.
Okay, perfect. Thank you so much. Well, we'll go ahead and get started. So for those who don't know, what is the GLM Science Meeting? So the GLM Science Meeting, what I'm going to be talking about today, is the 2020 version, but it's an annual conference-style summit between scientists, researchers, and forecasters who get together to discuss the development and analysis of the GLM instruments and the gridded products. So how are the GLM instruments performing? How are the GLM instruments being developed? And what operational uses or research uses are coming out of the GLM observations. It's typically held in person in the fall, but it has been virtual the last couple of years due to the pandemic. But this year we got the opportunity to do a hybrid in-person and Google Meet virtual conference that was hosted at on campus at the University of Alabama, Huntsville, in Huntsville. And so that was a great atmosphere to have that discussion style, everyone in the same room style session again. And that's a group picture of us in the lower right. So the structure of the 2022 GLM Science Meeting, it was spread out over 3 days, and there were 2-hour sessions, one in each morning and afternoon. So there were a total of 6 2-hour sessions over those 3 days. And those sessions included a plenary session, sort of an overall status update on the GLM program and instruments, as well as validation studies, operational uses, and some of the developing science and applications pertaining to the GLM and its observations. So we're going to jump right in. And before we move on, I just want to say that I'm not going to have time to mention every talk in this presentation, but the slides for the individual presentations are expected to be available at some point in the future, and we'll keep you posted on that. So for the plenary session, there were several interesting talks. Some of the big ones that come to mind are we got an update on the GOES-R gridded products with the operational GLM data at full maturity, and a ground system update of some of the testing that continues to be done as the GOES 18 instruments transition to operations, which they should become fully operational early next year. We also got a very interesting update on the progress of the Flight Model 4 GLM, which will be aboard GOES-U. That will be launching in April 2024 on a SpaceX Falcon Heavy rocket. And the instrument has already been affixed to the GOES-U satellite, and they're continuing to make progress there towards their launch date. And we also had a very interesting presentation about the development of the GeoXO Lightning Mapper, or the LMX. That's sort of the next generation Lightning Mapper. The plan right now for the GeoXO system is to continue to have an east and west lightning imager, like we do with the GOES-R missions, to continue to have geostationary lightning coverage that's at least as good as our current resolution through the end of the 2000s. So that's a really good news that we're going to continue to have that lightning coverage. Continuing on with the theme of GOES 18, how's it going? So we heard from Tewa Kapulin at Lockheed Martin about some of the hardware changes that are different on the GOES 18 GLM as opposed to the GOES 17 GLM. They made some hardware modifications that reduced the amount of stray light that was finding its way into the GLM sensor. So instead of sunlight beams going into the GLM and the GLM possibly mistaking them for artifacts, there have been some improvements there to reduce those number of false events, those solar intrusion events, which you may have seen pop up on the GLM occasionally. So that'll reduce the number of false alarms and improve the overall performance of the GOES 18 GLM as opposed to the GOES 17 GLM. We also got an update on the Meteostat third generation lightning imager that's going to be launched into space with EUMETSAT in December 2022. That's the plan, and that's going to provide geostationary lightning imagery for an entire new region encompassing most of Europe and Africa. So those are going to be lots of new forecasters with the ability to access those kinds of observations and hopefully apply them in their forecast operations. Jeffrey Stano from UAH also gave a very interesting presentation about the GHRC DAC. The GHRC is the Global Hydrometeorological Resource Center. It's basically one of NASA's weather data archives, and he did a very interesting talk showing how the lightning data sets, even though the file sizes were small, made up 7 of their top 10 most downloaded data sets. So it's certainly one of the most popular data sets that researchers are out there is lightning data. And we're working on getting the gridded products for the GLM into that publicly available GHRC DAC. That's a progress that is still in progress and still ongoing. And then also eventually down the line, we want to get the GLM gridded products like flash extent density and minimum flash area into NCEI as well. The session on validation studies began with a very important update from Eric Bruning at Texas Tech, talking about bounding the GLM flash detection efficiency with minimum event energy. So essentially trying to come up with a way to estimate the detection efficiency of the GLM instrument by using this minimum event energy product. So the idea is that with some fine tuning and some feedback from forecasters that hopefully we can make a quantifiable product that expresses some amount of data quality information that users definitely want and need for the GLM. So they're still in progress there, but at this point, hoping to develop something that can express that sort of reduced detection efficiency at times when we know that the GLM is susceptible to it. We also heard from Katrina Wirtz at UAH telling us her work on Monte Carlo simulations evaluating our perceived accuracy of the GLM detection efficiency and false alarm ratio. And she found that the bottom line was that optimal matching criteria are very different for detection efficiency and false alarm rate. So it's very hard to find the best way to compare those without overestimating or underestimating one or the other. So, you know, a broad matching criteria would overestimate the detection efficiency, but it's necessary to capture to correctly estimate the false alarm rate. So those initial detection efficiency estimates of greater than 90% may be a little too high. It's definitely exceeding instrument specifications of greater than 70%, but the false alarm rate values of around 5% appear to be generally accurate, at least for the GOES East GOES East GLM, which has an accompanying better ground sensor network. We also, continuing with the theme of GOES 18, we saw from Monty Bateman a very interesting presentation of the GOES 18 GLM as opposed to the GOES 17 GLM, and the animation there on the bottom right-hand corner is false alarm ratio between those two instruments, and you can see they're similar. There's differences in different places that we had an interesting discussion session about that we don't have time to get into here. But basically, the GOES 18 GLM is performing. They're continuing to do improvements to it, and it should be fully operational next year. So now we get to talk about a couple of people that I have the pleasure of working with here in my lab. So Daila Zhang did a very interesting presentation where she showed the work that she's been doing developing a Raspberry Pi camera network. And you can see the animation, the video in the lower right-hand corner is some of the automated recordings that she's been able to capture from some of her recording sites of lightning strikes with these Raspberry Pi cameras. And so these serve as high-speed, better than just trying to, you know, capture it with your iPhone speed of and location accuracy and timing and location accuracy of these confirmed and observed lightning strikes, which serve as a good ground truth for both our local lightning mapping array that we operate here in DC and the GLM observations from space. And speaking of that lightning mapping array, Guangyong Fang gave a riveting presentation about how the Mid-Atlantic lightning mapping array, which is an amalgamation of the DC lightning mapping array and the Wallops Island, lightning mapping array, how that combined network managed to capture some of the very interesting lightning activity from some of the severe thunderstorms that were ongoing in the College Park area actually this past summer. So shifting now into the operational uses, the first talk I want to get into was from Javier Villegas Bravo, who actually works here at UMD CISESS, and he works closely with the Ocean Prediction Center. And his presentation for the 2022 science meeting, GLM Science Meeting, was on how the OPC is expanding their nowcasts using the Prob Severe Lightning Cast product. So the Prob Severe Lightning Cast takes inputs from satellite data and creates a gridded a field of probabilities that lightning is about to be observed with the GLM. So those testbed results, by integrating that lightning cast product within OPC, showed that OPC forecasters found lightning cast to still be a reasonable and useful product in lightning prediction, even over the maritime regions that they're mostly responsible for. And there some interesting imagery that he showed of them incorporating that lightning cast product and being able to accurately stay into their text products, expect thunderstorms and not just rain showers. And then he also surveyed some of the forecasters and asked them how they felt most comfortable using it. And one of the interesting results there was that more forecasters listed the 50 to 75% range as giving the best actionable lead time as opposed to any of the other probability bins. So once you start getting past that halfway 50-50 point, that's when forecasters felt the most confident that like this lightning cast product is adding value in the moment and telling me that lightning is about to be possible in this area. We also saw a very great presentation from Kevin Thiel at CIRO on the update from the 2022 summer hazardous weather testbed proving ground experiment that concerned the GLM. Most of the forecasters found flash extent density and minimum flash area to be very useful for them. 2/3 of it cited the GLM, the unique spatial extent of the lightning flashes from the GLM in their DSS messaging, citing that the aerial extent of those flashes was very important to them to make sure that they kept their partners safe in those experiments. And a lot of them really had confidence in increasing confidence in their warnings when they saw that there was either increasing flash extent density or decreasing the minimum flash area with those stronger updrafts and convective cores. I gave a quick presentation on the GLM training resources and forecaster development. I talked about some of the comment modules and Satellite Book Club presentations and FDTD webinars that have been presented to try to develop the operational understanding and use of the GLM instruments. So one of the most interesting presentations that I definitely want to make a point of showing you all today came from Brianna Woodwell, who was the NOAA La Pinta intern this past summer. And just part of her work showed that you can take the background imagery that the GLM creates as a part of its processing, and you can actually import that into AWIPS. So for those who don't know, the GLM creates a background in the full disk every two and a half minutes, and that has an 8-kilometer resolution at nadir. And that imagery is it's very akin to visible satellite imagery. And what Brianna proved was that you can both import that imagery into AWIPS, which is very important, and that you can also expose that imagery to forecasters, and they will have an understanding intuitively of how to use it similar to visible. So she explored showing this sort of imagery to 5 different WFOs, and she got comments that, it looks like an older version of GOES, or, I didn't think it would be that good. And definitely all the forecasters said that in the event of an AB outage, that they could forecast off of this GLM background imagery. So she did some very important work working with Lee Byerly and Joe Zajic to confirm that these GLM background images can find their way into AWIPS. So that's something that I think is very interesting and could be very useful to forecasters down the road. We had several presentations on bolide detection with the GLM. So bolides are bright flashes of light in the sky. They're basically meteors crashing into Earth, and those bright flashes of light are very similar to lightning. So the GLM can confuse it for lightning and treat it as an observation, but that actually turns out to be really useful for astronomers. And other people who are just involved in the science of space. So the couple of the interesting presentations we got, one was from Jeffrey Smith, who works for SETI, the Search for Extraterrestrial Intelligence, and they were talking about how they have a wide field of view with the 2 geostationary satellites, and that also the overlap region between the 2 of them allows you to get these stereo observations where you've got the GOES 16 seeing it and you've got the GOES 17 seeing it, and where they intersect, you can actually get a rudimentary height estimate of where exactly that bolide was occurring in the atmosphere, which is very useful for astronomers. Randy Longenbaugh from Sandia also showed that the GOES 17 and GOES 18 GLMs, even though they're in very similar locations with very similar specifications, that the light curves of energy received and the locations of ground tracks can vary between the two instruments. Next, I want to talk about the presentation from Anil Roy at UAH NASA Sport. They talked about regional day cloud phase assessment with the GLM and NLDN. So some background was that NWS Jacksonville had shown in their research that day cloud phase RGB was useful for lightning IDSS guidance. It would show that there was glaciation occurring, and that would provide sort of a precursor or an upfront warning before the lightning actually occurred, and give them some time to anticipate it. So they assessed that day cloud phase product across several regions in the Weather Service: Eastern region, Western region, Southern, Central, and Alaska. And they observed that glaciation preceded the observed lightning from GLM in almost all cases. And they had a varied number of cases across the region. They were trying to assess, are there any regional trends in that day cloud phase assessment? Is it more reliable in the Southeast, but maybe not so reliable in Western region? And they didn't find any significant trends between GOES East and GOES West, but they did find that there was a broad range of lead times in all the regions. And so more research might be needed to see if there's any sort of differences in that natural glaciation of first flash intuition that forecasters use with these satellite products. We also heard from Steve Goodman from NOAA NASA about the lightning as an essential climate variable, which the World Meteorological Organization affirmed. The lightning is a significant source of trace gases in our atmosphere, like NOx, and it also affects things like aerosols, temperature, clouds, precipitation. And so the lightning as an essential climate variable means that there's going to be more standardized observations and more emphasis put on it as understanding how lightning relates to our changing climate, and it's going to really affirm those lightning observations as being central to understanding how our climate is changing. Scott Rudlowski from NOAA NESDIS presented on GLM lightning strikes and wildfires in the western US, and tried to do some detailed matching with the location and timing of GOES 16 and GOES 17 GLM flashes and wildfire locations. He's continuing to progress with very interesting work on that, which I think you may see some interesting animations from him in the future. We also heard from Michael Stock at CIRO on thunder hour observations. So this is, thunder hour, intuitively, it's just, is there an hour where someone would hear thunder at this location? And thunder hours, they may seem not the best way to observe it, but if you think about it, that's actually the oldest lightning variable that we have on record, is that people would record, oh, we heard thunder, and that's how you know there was lightning that day. So the thunder hour observations and comparing those to the new instruments are very important for those kind of climate studies. Interesting talk from Levi Boggs at Georgia Tech Research Institute about identifying tornadoes using the GLM and machine learning. So basically feeding in, the number of flashes, the duration of flashes, and the area of the flashes to a machine learning algorithm, and trying to use that to estimate the occurrence and the strength of the tornadoes. And he found that it had a pretty reasonable probability of detection and a reduced false alarm rate as compared to just using radar alone. And so that he definitely stressed the need for more results, but those are very interesting results, and he's going to continue looking at that research. Jessica Lasogo, also from Georgia Tech Research Institute, gave a very interesting presentation about the GLM flash trends for a long-lived supercell. She called it the megagraph, and there's an example of it on the left-hand side, showing where we had lightning dives and lightning jumps and different life cycles of the storm, and comparing that to when tornadoes were occurring. And there were, lightning jumps that were observed, but one of the interesting things was that there were significant lightning dives where lightning activity fell off very quickly. That's just total flash counts, and the dives were both just before and during the tornadoes. So there's some scientific basis there that the dives could serve as an actual indicator that the tornado will form. Yeah, we know that surges in the RFD and getting that less buoyant than the inflow, but still slightly buoyant RFD air into the updraft can be a significant source for tornadogenesis. So that might actually slightly decrease the strength of the updraft and lead to less lightning at that point of tornadogenesis and tornado maturity, which was very interesting. And then also there was a discussion of the reevaluation of the 2 sigma level for the lightning jump algorithm. Maybe something more appropriate, like 1.5 sigma may be appropriate. The GLM Spotlight product was one of my favorite things that I got to experience at the GLM Science Meeting this year. Kelly Murphy from UAH NASA Sport gave a very interesting talk about how they've developed this website, and the link is there. We'll try to share that later. But it's basically adapting the 30-30 rule for operations in the GLM using a red, yellow, green stoplight method. So in the imagery on the right-hand side, the red is lightning within the last 0 to 10 minutes. Yellow is lightning in the last 10 to 20, and then green is 20 to 30 minutes. So that gives an intuitive spatial way to interpret the GLM observations and apply it to something that people are already familiar with using in their day-to-day lives as a lightning safety technique, which is the 30-30 rule. And there, the different website configurations you can pick there in the NASA Sport Viewer. So now getting into the science and applications sessions, there was a very interesting talk from Jonathan Wynne-Smith at GFDL comparing the GFDL C96 climate model flash frequencies and the observed flash frequencies from the GLM, and found that the GFDL model often underdoes the flash counts, and so that could have significant ramifications on making sure that the climate model is, say, for example, producing the right amount of trace gases and then incorporating that into its atmospheric chemistry. So that's something to take into consideration. Also had a great talk from Kelsey Brunner at Texas Tech about microphysical signals in lightning track thunderstorms, and that using the lightning first as a tracking method was able to capture the major microphysical features, including KDP and CDR column strength. There was also a very interesting talk from Jacqueline Ringhausen at CIRO about regional and seasonal variation in the GLM flash classification of intracloud or IC versus CG cloud to ground flashes. And she found that maximum group area, so the largest area of any group within each pixel, and then the time of day were the 2 most predictive variables for determining whether a GLM flash was intracloud or cloud to ground. And there's still very interesting work being done on that. Kyle Hilburn from CIRO presented on enhancing tropical cyclone forecasts using the GLM. They investigated several hurricanes and tropical cyclones, and found that there was a downshear left lightning preference when those storms are undergoing rapid intensifications of increasing 30-knot wind strength over 24 hours. And but that preference for downshear left was less strong when the storms were weaker or even weakening. So you tended to have more lightning closer to the innermost 100 kilometers and less lightning overall, and slightly more lightning in that downshear right as opposed to downshear left for tropical cyclones. Feng Zhang from my lab here at UMD also presented about blending the space-based and ground-based lightning networks to try to create this unified product, which could be uniformly used for lightning data assimilation. And her work has been very, very interesting, ongoing, to see how you have to tweak these different data sets to get them to show a blended lightning product. We had a very interesting talk from Earl Williams at MIT about cold air outbreaks and global lightning, and how that pertains to how say strong cold fronts coming over from across the Americas can lead to a significant reduction in global lightning activity, and how that relates to the lightning production in those areas and across the globe. And we also saw from Elise Schultz at CFD Research a very interesting presentation about short-term lightning prediction tools for commercial and public sector applications. They are working on getting an API release to customers late this year, early next year, that will allow them to share this lightning data in a more straightforward way with the public sector. And they have a Lightning Nowcast product coming out in early 2023 as well. So, this allows the private sector and public sector to have better access to these spatial lightning observations. And Patrick Gatlin also gave an update on the CubeSpark 3D lightning mapping concept, using multiple satellites to create a 3D map of some of the GLM flashes. Bill Koschak, Marshall Space Flight Center, NASA, gave an update on the GLM National Climate Assessment Analysis, and he specifically talked about the Lightning Monitor, or LIMO tool. That's a tool for assessing how the lightning counts or lighting attributes are changing with a changing climate. It was written in Wolfram Alpha, and it ingests the GLM 16 and NLDN data sets. So it really supports that national climate assessment of how does the changing climate affect the U.S. lightning, and this is one way to assess that. Vincent Salinas from CIRO gave a very interesting presentation about GLM flash energy for climate study applications, which is very important when determining the amount of trace gases as a result of thunderstorms. And then Florian Marves from Texas A&M Corpus Christi, very interesting presentation on determining lightning clouds by applying neural network models to GMI brightness temperatures. So they were trying to use a neural network to differentiate lightning producing precipitation from non-lightning producing precipitation by using the GLM as the truth data set for lightning. And they found that they were overestimating, but still getting a good general spatial area of the right lightning producing precipitation. Zhao Huaman-Chinche, who works at Tsunami, which is the Peruvian National Weather Service, gave some very interesting results about his work on the frequency and distribution of GLM lightning over South America. They're working on developing or extrapolating a nowcast of precipitation product using the GLM flashes. That's going to be very useful for them in their data sparse regions, especially in mountainous regions. Stetson Rieger from New Mexico Tech gave a very interesting talk about single flash mapping with the GLM. They tried to basically take a large single flash and compare the GLM observations with an LMA observations, and they found that the LMA sources and the GLM group centroids actually lined up fairly well. So that was very interesting to see that work. Phil Bitzer from UAH also gave an interesting presentation about single group flash analysis and reprocessing. So the single group flashes with the GLM are assumed to be noise and tossed out, but a significant portion of them may be actual lightning flashes. So that his talk was basically highlighting just the potential there is to improve the overall detection efficiency of the instrument by trying to preserve some of these single group flashes. And then finally, we saw from David Singlewood at Texas Tech a comparison of the different lightning, space-based and ground-based lightning observation networks while they were photographing two CG strikes. So they have this observation on the ground, and they compared it to the networks. Interestingly enough, the GLM did not observe those two flashes for whatever reason, but the West Texas lightning mapping array did, and the ground-based networks did. And so that was an interesting comparison. It'll serve as a reference point for why did one network see it and the other, and that research is ongoing. So in summary, the GLM continues to provide unique space-based spatial observations of lightning. Improvements continue to be made with the newer instruments. We've got the GeoXO instruments coming over the next few decades, and those are at the time planning to have those lightning mappers continue to provide coverage over the next several decades. We saw that the GLM observations and gridded products have many uses in forecasting and a broad range of uses elsewhere in the public and private sector that are still just being discovered. And so I'm excited to see how that continues to evolve and change as we go forward. Lightning is an essential climate variable, and it reaffirms the emphasis of accurate climate lightning modeling so that we can accurately understand our changing ecosystem. The GLMs will continue to provide geostationary lightning mapping coverage for the next several decades with the GOES-R and the upcoming GeoXO missions. And for as far as the slides here, we will hope to get them out to you in a reasonable time frame so you can peruse them at your leisure. My contact info is there on the bottom. That's all I have for now, so thank you so much for having me today.
All right, thank you, Joseph. We will have a little bit of time here still, so if you could please stay on for a little bit for some discussion. There has been some discussion in the chat, but if you have some additional questions you'd like to ask, please put them in the chat or let us know and we can try to unmute you. I was specifically interested if anyone that are in the field offices that have used GLM have any questions about any of these topics that came from the meetings that just was at, those be great. And a couple things before we jump into questions is do want to mention that a week from today on Thursday, October 13th at noon Eastern time, we have Dr. Rebecca Ismail from Science and Technology Corporation to discuss satellite data visualization within Python. And if you have any other questions, please at any time contact the Towers S team, Lee Byerly and Kashad Bowman for any questions about the SBC or any configuration of any products talked about in any of these talks. Before we get started here, there was some discussion. I believe they were talking about the marine satellite products that you talked about. Eric talked about any research or discussion about lightning cast false alarm ratio in the west, pulse storms that are that reach the golden 50 to 75% probability range can often not generate any lightning before the storm collapses. And there was a response from Javier that said, in the test bed, we found that the false alarm rate over the ocean was an issue, but that it was still reasonable for a swath of lightning where it may go off for it. And then kind of talking more about, talking marine events versus land and looking at the CONUS domain versus tropical and how tropical didn't necessarily match up with that. So was there anything else you would like to add to that, Joseph, beyond what was added in the chat there?
No, I think Javier did a great job of replying there. That was his work. He's the expert. So thank you, Javier, for jumping in there. And I agree that I'm glad you addressed those concerns about FAR in the testbed.
All right, thank you for that. So another question brought up, another question that I've gotten here is, what new insights into the GLM lightning observations and operations were discussed during the meeting that you're at, the 2022 GLM Science Meeting, that you'd like to talk about more?
Sure. Well, I think there were two that really come to mind. The first one is the work that Brianna Witherell did, showing that the background imagery for the GOES 18 GLMs can still be brought into AWIPS and can still be useful to forecasters. And this was just part of the work that she did this summer. And I think it's pretty incredible. This tropical cyclone here is Hurricane Darby over the Pacific Ocean in 2022. And so to prove that this imagery is useful and coming out of the GLM instrument and accessible in AWIPS, I think could be very important, especially if there's any sort of ABI outage. And then the other thing I wanted to mention would be the GLM Stoplight product from Kelly Murphy at UAH NASA Sport. And that viewer is at that link here. I'll go ahead and post it in the chat. And this allows you to sort of have an intuitive product that you can use as a forecaster with IDSS applications, or you can share with others and adapt that 30-30 rule, which I think a lot of people have had ingrained in them at this point. And so to have a visual version of the 30-30 rule, I think is very, very cool for forecasters.
All right, thank you for all that. Are there any other questions anybody has in the chat? Please enter them now. There was also some other discussion going on looking into, was there any discussion at the meeting talking about anything related to the MRMS Prop Severe Lightning Probability product? And if any new research on that was going to be making its way into NWS officers or some other similar operational setting anytime soon.
I don't recall there specifically being a presentation about that. We did hear about, we talked about the Prop Severe Lightning Cast product, but definitely keep your eyes and ears open for that. There's always new training coming out.
All right. Well, with that, that's all the questions I've seen. We can maybe hold for another minute here to see if there's anything anybody was working on typing up, but we'll give it a little bit and then we can go into closing comments. All right, well, thank you all for attending here today, and I'll pass it back off to Brian for any final remarks.
All right, thank you, Nick, for your facilitation today, and thanks, Joseph, for this nice summary of the workshop. It was actually one I wanted to attend, but had some previously scheduled leave, so I appreciate the overview, as I'm sure many of our operational team here participating will take a deeper look into some of these materials. So thanks very much for the briefing, and very helpful, very informative. And also, as Nick said, please join us next week, where we'll have a talk from Dr. Ishmael's STC, talk about satellite visualization using Python. Thanks very much for your participation today, and we look forward to seeing you next week.